cos of x square is a composite function. So we are going to use the chain rule here. So derivative of e power anything is the same, that is e power x square, but x square is another function and its derivative will be 2x. What does the product rule says? U into v whole dash can be written as u dash v plus v dash u. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Vidhyaashram School of Excellence, Mysuru. So in last session, we have studied how to derive the different types of functions. So from this session, we are going to take problems on different types of function. In today's session, let us see a very small functions of 1 mark questions, which is important for your examinations. Question here. Find the derivative of cos of x square with respect to x. So, before finding the derivatives of any types of functions which we have studied in our previous session, that it may be an implicit function or a parametric function or inverse trigonometric function or a composite function, you should know all the standard derivatives of the certain functions. So, now we know the standard derivatives of some functions given here, that is for cos x it is minus sin x, and x square, since it is in the form of a polynomial x power n, its derivative will be in the form of n into x power n minus 1. So therefore the derivative of x square will be 2x. Now here cos of x square is a composite function. So we are going to use the chain rule here. So therefore let me take here y is equal to cos of x square. Derivative of y is nothing but dy by dx. Cos of x square is minus sin of x square. Again we have to derive x square because it is a composite function. So chain rule, using chain rule. So once you derive it, we get here minus sin x square. What is derivative of x square? It is 2x. Or you can write it as minus 2x sin x square. So this is the derivative of the given function. So whenever composite functions is given, use chain rule. Next, find the derivative of e power x plus e power x square plus e power x cube plus e power x power 4 plus e power x power 5. We know the derivative of e power x is e power x only. But here in the other 4 terms here, you have x square, x cube, x power 4, x power 5, which is a polynomial function, and hence we use the derivatives in the form of n into x power n minus 1. So let me take here y is equal to e power x plus e power x square plus e power x cube plus e power x power 4 plus e power x power 5. Let us go on deriving it directly. So dy by dx. What is derivative of e power x? It is e power x. Again, consider this in the form of e power x only. So derivative of e power anything is the same, that is e power x square, but x square is another function and its derivative will be 2x. Use a chain rule concept here also. Next we have e power x cube. Derivative of e power x cube is e power x cube only, but you have to derive x cube also, which becomes 3x square. Next, we have e power x power 4. So here we have 4x cube. And finally, we come across e power x 5. And here we have 5x power 4. So that is, you should derive the other polynomial function also. So therefore, here you get e power x plus 2x e power x square plus 3x square into e power x cube, 4x cube into e power x 4, 5x power 4 into e power x power 5. So this is the derivative of the given function. Next one, find the derivative of log x with respect to x. We know for a log function, its derivative is 1 by x. But here you have log x. So let me take y is equal to log x. So log of anything will be in the form of 1 by x only. So therefore this can be written as, here it becomes dy by dx is equal to log of x. If you take, it will be in the form of 1 by x. So this becomes 1 by log x. But this is not simply x, it is again log x. So derive it once again. What is the derivative of log x? It is 1 by x. So therefore, what is the derivative of this function? It is 1 over x into log x. This is the derivative of the given function. Next, cos of sin x. So let me take y is equal to cos of sin x. So first let me derive for cos function and then we'll derive sin x function. So therefore this becomes dy by dx. Cos of any function or cos of any value will be equal to minus sin, because cos x derivative is minus sin x. So therefore cos of sin x becomes minus sin of sin x. Again differentiate sin x because it is one more function here again. So what is the differentiation or derivative of sin x? It is cos x. So thus this is the derivative of the given function, that is minus sin of sin x into cos x. Find the derivative of secant of tan of root x. We know the derivative of secant x is secant x tan x. Derivative of tan is secant square x and derivative of root x is 1 by 2 root x. So from this, if you take y is equal to secant of tan root x. So here we have three functions. One is secant, tan and square root function. So we will be having three derivatives. So let us use the chain rule here. First let us derive for secant function. What is secant of tan root x? It is secant of tan root x into tan of tan root x. Now it's done. We have done with secant function. Now let's derive only tan root x. What is the derivative of tan function? It is secant square. So therefore this becomes secant square root x. Now tan is also done. We'll derive root x. What is the derivative of root x? It is 1 by 2 root x. So this is the derivative. So clearly you can see this is the derivative of the given function. Or you can rearrange this, write it in the form of secant square root x into secant of tan root x, tan of tan root x whole divided by 2 root x. So this is the derivative of secant of tan of root x. Next, if y is equal to 3 e power 2x plus 2 e power 3x, find dy by dx. So here we have already y. So let me find out dy by dx. Any constant with the function, write as it is. So we have 3 here, 3 into e power 2x. Derivative of e power x is e power x only, but here we have e power 2x. So after taking the derivative of e power 2x, we have to differentiate 2x again. Now into e power 2x. Now again derive 2x. So what is the derivative of x? It is 1. Since we have 2 along with x, it becomes 2 into 1, which becomes 2 here. Okay. Next here we have 2 into derivative of e power 3x is e power 3x. But again derive 3, you will get 3. So multiplying this, we get 6 e power 2x plus 6 e power 3x. So this is the derivative. Next, find the derivative of tan inverse x assuming it exists. So I have already told you. So no need to prove the derivative of any inverse trigonometric function. Just learn the standard answers for this. So we write if y is equal to tan inverse x, then dy by dx is 1 over 1 plus x square. So this is the standard derivative of tan inverse function. In the similar way, they can ask you for sine inverse, secant inverse x. Just learn the derivatives and write directly dy by dx for 1 mark question. Find dy by dx if x minus y is equal to 5. So here you can see both x and y are on the same side. You can consider it as an implicit function, or you can convert this function into y and then find dy by dx. So if you convert this, you will get y is equal to x minus pi. So when you derive it, it becomes dy by dx, derivative of x is 1, derivative of any constant is 0. Or you can directly derive like that only. Derivative of x is 1, y is dy by dx, constant is 0. So see here, or deriving it directly, derivative of x is 1, derivative of y is dy by dx, and derivative of constant is 0. So what is dy by dx? So we get dy by dx is equal to 1. Whether it is an implicit or explicit function, finally convert dy by dx and find the answer. Next, y is equal to tan of 2x plus 3, find dy by dx. So let me write dy by dx. So what is the derivative of tan function? It is secant square function. So here it becomes secant square of 2x plus 3. It is done now. Again we have to derive a polynomial function which is inside the tan function. So let us derive d by dx of 2x plus 3. So when you know it, that is you have to derive using chain rule, directly go on deriving each and every function given. So this becomes secant square 2x plus 3. Now what is derivative of 2x? Derivative of x is 1. So 1 into 2, it becomes 2. What is derivative of 3? It is only constant. So therefore it becomes 0. So we can write here the answer is 2 into secant square 2x plus 3. So this is the derivative of the given function. So next question we have, find the derivative of e power sine inverse x with respect to x. So here let me take y is equal to e to the power sine inverse x. So now we know the derivative of e power x is e power x only. So we will write here dy by dx is equal to, what is the derivative of e power x form? It is e power x form only. So here we get e power sine inverse x. But sine inverse x is again one more function. So let us derive sine inverse x. So what is the derivative of sine inverse x? That you have to write it here. So this becomes e to the power sine inverse x divided by, because sine inverse x is 1 over root of 1 minus x square. So this becomes like this. So derivative of the sine inverse function is 1 divided by root of 1 minus x square. So when you multiply it, the answer or the derivative for this question is the given result. Next, find dy by dx if x is equal to a t square, y is equal to 2at. So here both x and y is represented with the help of t. That is, this is an example for a parametric function. So let us derive dx by dt and dy by dt, and then we will find out dy by dx. So we have x is equal to a t square. So here we are going to differentiate with the parameter t. So therefore we write it as dx by dt. So when you are differentiating with respect to t, use same rule as in the case of x you have learnt. So a is a constant. What is the derivative of x square? It is 2x. So therefore what is the derivative of t square? It is 2t. So this becomes 2at. Next we have y is equal to 2at. Let us derive it with respect to t. So 2 is a constant, a is a constant. So therefore t is a variable we take. What is the derivative of x? 1. Same way, what is the derivative of t? It is 1. So 2a into 1, which becomes 2a. Now we will find out dy by dx. So how we can find dy by dx? This can be done by dy by dt over dx by dt. What is dy by dt? It is 2a. And here what is dx by dt? It is 2at. So cancel this 1 by t. So this is the derivative. Find the second order derivative of the function x into cos x. So second order derivative is nothing but deriving the same function twice. So let me take y is equal to x into cos x. So here we have two functions in product form. So let us apply the product rule. So what does the product rule says? U into v whole dash can be written as u dash v plus v dash u, or you can take it as uv dash plus vu dash. So any of the form you can take here. So here let me write dy by dx is equal to first function into derivative of second, that is minus sin x, plus second function into derivative of first, that is 1x. Or you can take derivative of first into second function plus derivative of second function into first function. So first function derivative of cos x is minus sin x, plus second function as it is derivative of first function, here since it is x, its derivative is 1. So therefore what is dy by dx? So dy by dx is minus x sin x plus cos x. Now dy by dx is a first order derivative, again differentiating. So again differentiating, we get d square y by dx square. So let us keep minus outside. So let us apply the product rule, because we have here two functions. One is x, another one is sin x. So first function into derivative of second, that is cos x, plus second function into derivative of first, which is 1. So let us keep it as it is, plus cos x. So therefore d square y by dx square is equal to minus x cos x minus sin x plus cos x. Next, find the second order derivative of the function sine of log x. So let me take y is equal to sine of log x. It's a composite function. So first let us derive dy by dx. So what is sine of log x? It is cos of log x. And what is derivative of log x? It is 1 by x. So therefore this becomes cos of log x divided by x. Now I need to find out d square y by dx square, that is second order derivative. So now here we will apply the quotient rule, because the function is in the form of u by v. So what does the rule says? U v dash minus v u dash divided by v square. That is first function derive second minus second function derivative of first divided by square of the second function. So now applying this rule here. So this is u now, this is v now. So u v dash means cos of log x as it is. And derivative of v, that is x is 1, so no need to write it. Next is v, which is x. Again differentiate cos of log x. So when you differentiate cos of log x, it becomes minus sine of log x into, what is derivative of log x? 1 by x. So whole divided by v square, which becomes x square. So here I can cancel x, x. So therefore d square y by dx square here becomes cos of log x, minus into minus becomes plus sine of log x whole divided by x square. So the next question, find dy by dx if x is equal to a cos theta, y is equal to a sin theta. So here we have x expressed in the form of theta and y in the form of theta. So let us derive both with respect to theta. So now let us take x. X is equal to a cos theta. So differentiate with respect to theta now. A is constant. What is the derivative of cos x? It is minus sin x. Similarly for cos theta, it is minus sin theta. So therefore this becomes minus a sin theta. Now let us take y. Y is equal to a sin theta. So what is the derivative of sin theta? It is cos theta, and a is constant there. So therefore write as it is. So now let us find out dy by dx. So what is dy by dx? Dy by dx can be written as dy by d theta over dx by d theta. So what is dy by d theta there? It is a cos theta, and dx by d theta is minus a sin theta. So a get cancelled. What is cos theta by sin theta? It is cot theta. We have minus there. So the derivative of the given function is minus cot theta. So in this session, we have taken very simple questions of 1 marks of different form of functions and its derivative. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.